GitOps is a declarative workflow model for deploying applications and managing cloud and Kubernetes infrastructure through Git, the de facto version control system. It serves as a single source of truth, providing benefits such as revision and change control. With a declarative model, instead of individual team members managing Kubernetes via command line scripts or GUI and storing configs on their laptops, you describe config manifests in advance in Git and automate any changes using a Kubernetes controller with a pull-based mechanism, essentially automating the current state of the system into the desired state as described in Git. With GitOps, you now have a recoverable system. It's a self-healing system, enabling traceability, determining what changes were made, when, by whom, and why. Let's take a high-level view of GitOps in action. So in this example, we see that we have developers as well as operating teams or infrastructure teams that are working together. And developers will typically use Git as a source control system, as we mentioned, and they'll commit their software code into Git. This will kick off a pipeline when they use a CI tool, continuous integration tool. This will do some scanning and testing of that software and move that over into an image, a container image. And this image is hosted in an image repository. Now the CI tool could be Circle CI, Jenkins, or even something running on Google Cloud. The image repository could be Docker Hub, it could be JFrog, or even Container Registry on Google Cloud Platform as well. So as software is moved from CI into the image repository, an image ID will be updated in Git. And this will kick off a few steps in the process. And we'll come back to that in a second. Now, the infrastructure team is typically managing cloud and Kubernetes. And they'll leverage comfortable tools of choice such as Ansible, Terraform, or other Kubernetes-specific configuration tools to build manifests. And what they're doing with GitOps is they're essentially describing the state of the cluster in advance into the single source of truth. So at any time, if you're looking at the state of the environment, you're looking at Git. Now, as the engineers move that configuration manifest into Git, this will kick off a process, as we mentioned earlier, similar to as with CI. And to do that, we're leveraging an agent. This agent is a controller that runs in Kubernetes. You can build this controller, or you could leverage open source tools such as Flux from the team at Weaveworks, or Argo, or even config management from Anthos. And what this tool will do, this agent, it'll essentially look for any divergence in the configuration state. So it'll compare the current configuration state as to that which is described in Git. And it'll leverage a pull-through mechanism. In other words, if there's any change, it'll apply that change into the Kubernetes cluster. So instead of the infrastructure team having to do kubectl apply and having multiple individuals do that, we leverage a single controller to operate that change, which is constantly monitoring, again, any divergence inside the Git repository or Git branch. These are just some of the examples that we can drive leveraging a GitOps model. Now, more organizations are also looking at self-service. As you add additional departments, they may require a namespace or an additional Kubernetes cluster. How can we automate that experience? How can we automate those requests? Perhaps with a self-service portal or even a service catalog that front-ends these requests and leverages an additional controller on Kubernetes to carry out or automate those configurations. In other words, what typically took months to configure and build and enable for your additional teams now takes minutes when we're leveraging cloud as well as GitOps. To learn more about GitOps, reach out to us at cloudmatos.com.